Hey guys, what's up everybody? Welcome or welcome back again to another video tutorial from the Apex Academy of Mathematics. We are learning the language of the universe begins here. My name is Akin, otherwise known as Apex Selenium, and in this video, which is the part 2 of a 2-part series in the Simultaneous Equations marathon, where we're going to be going through a variety of questions where we're going to be learning how to actually apply the elimination method versus the substitution method, which method is best, when, where, and why. Of course, do check out the video that I've made before this. The link is in the description below. Alright, so without further ado, let's pick up from where we left off and run through the remaining 9 or so questions. Okay, alright, so let's get to it. Alright, and of course, I have to make sure that you don't forget to smash the subscribe button below and drop a like on the video, and of course turn on your post notification bell for future video tutorials. Okay, so let's get to it. Alright, so we are asked to solve the simultaneous equation 3x minus 2y is equal to 14 and x plus 2y is equal to 10. Alright, so what I recognize here, guys, is an easy opportunity to use the elimination method. Alright, that's what I recognize here. I also see an opportunity here to use the elimination method, so it really comes down to personal preference. I'm in between decisions here, but because my eyes first catch the opportunity to use the elimination method, because I recognize here that these two coefficients are the same, I'm just going to work with that method for now. All right, but I do encourage you to apply the substitution method if possible as a practice exercise, so you can make X the subject and do your little thing. Okay, all right, but for this one I'm just going to be using the elimination method, so let's just get to it. So starting out by calling this here my equation 1 and calling this my equation 2. The signs are the coefficients are the same, so I'm good to go. I don't need a third or a fourth equation, so all I have to do now is just to add to eliminate. So I'm gonna have equation 1 being added to equation 2, and that implies I'm gonna have 3x plus x, and that's going to be equal to minus 2y plus 2y, and that's equal to 14, of course, minus, well, plus 10. Okay, so now I have 3x plus x, that's equal to 4x, and negative 2y plus 2y, additive inverse identity, that's equal to 0, and of course 14 plus 10 is 24. So if I divide both sides here by 4, I'm going to easily get x to be equal to 6. Okay, all right, so substituting 6 for x in, I'm going to choose equation 2. Why equation 2? Of course, simply because the coefficients are small and easier to manipulate. All right, but you can choose equation 1 if you like. It's going to be the same result. So what I have here is that x is 6, so this becomes 6 plus 2y, and that's equal to 10, and of course bring that over there. 2y is equal to 10, subtracting 6 from both sides over here and over there, minus 6, subtract 6 over here, that's 0, and so we have 2y, and that's equal to, of course, 4, and of course y is equal to 4 over 2, y is equal to 2. Okay, so x is equal to 6 and y is equal to 2. Right, so guys, I hope you got that one perfectly correct. All right, and the same procedure, guys, as how I'm using this with regular numbers is the same way how you do it with decimals or even fractions. Fractions may be a little bit, may need a little extra something on it, but of course it's more or less the same. Okay, so hopefully I'll have videos on how to work fractional simultaneous equations, but that question is not so much prevalent on exam papers. It's more likely on class textbooks or so. You're going to find those kind of questions. Okay, so let's get into the remaining methods or questions. So what I see here is the best method and the easiest method here is the elimination method. Why? I have different numbers as my coefficient for my variables. I have a 3, a 5, a -3, and a 2. So when I see that, I think about nothing else except for the elimination method, which suggests to me here I'm going to need a third and a fourth equation. Okay, so here we go. Equation 1, equation 2. I'm going to be using the interchange coefficient technique. So here I'm going to multiply I'm going to multiply this bottom equation here by 5 because the coefficient here is 5 and the coefficient here is 3, ignoring the sign. Alright, remember, same signs we subtract, different signs we add. So we have a rule to help us with our signs, so we can ignore the signs when you're choosing these numbers here. Okay, alright, here we go. So 3 times 3x, that's going to give us 9x. 3 times 5y, that's going to give us 15y. And 3 times 1, that's going to give us 3. That's equation 3. Okay, that is equation 1 times 3, and that's what it implies. So equation 2 now times 5, that implies that 5 times 2x is 10x. 5 times -3y, that's -9y. And 5 times 7 is 20. Oops, not 21 but 35. That is equation 4. Let's double check our calculations. 5 times 2x is 10x. 5 times -3y is -15y. There we've made an error, so that could have cost us a little bit later on. So that's -15y. Okay, and 5 times 7 is 35. Alright, I think we're good to go. Alright, so now what we're gonna do here is, let's just write this a little bit better, it's a bit spacious. So y and y here. Okay, alright, good. So now that we have that, the signs are different, so we're going to add. Okay, so adding this, we're gonna have 19x, and adding that, we're gonna get 0, and adding these two, we're gonna get 38. So what we have here is x is equal to 38 divided by 19, x is equal to 2. Okay, so we're gonna substitute 2 for x in equation, let's use equation 1. I like that one. Equation 1 is good. So we're gonna have in equation 1, okay, so 3x plus 5y, where x is 2. So we're gonna have, okay, 3 times 2 plus 5y, 3 times 2 plus 5y, and that's going to be equal to, so 6 plus 5y is equal to 1. And subtracting 6 from both sides, we have 5 is equal to 1 minus 6. 5y is equal to -5. 1 minus 6 is -5, and y is equal to -5 divided by 5. And so easily we get y is equal to -1. So y is equal to -1 and x is equal to 2. Okay, so hopefully you guys got that. That looks to be working out for you. I think at this stage you guys are supposed to be okay, but let us continue and proceed and see if we can find any more challenging questions to push us to our limit. Alright, so here we have is to solve the simultaneous equation. 3x minus y is equal to 23, and 2x plus 3y is equal to 8. Again guys, whilst I can use the elimination method here, of course, I first catch the idea, or the first thing that catches my eye, I'm so sorry, is of course to use the substitution method. Reason being, I spot a variable right here with a coefficient of -1, so I can make that letter or that variable rather to be my subject. So right away, here's the substitution method. I'm going to first say from equation 1, that would be this equation. From equation 1, I'm going to say y is equal to 3x minus 23. Alright, So again guys, what I actually did here guys is that I brought the y to that side, so it became positive, and I brought the 23 over here, so it became negative. So that's how I got this third equation here. Okay, so hopefully you guys are not confused here. All right, good. So let's get into it. So now we're going to substitute 3x minus 23 for y in equation 2. Okay, so that's equation 2 there. So we're gonna have 2x plus 3 times 3x minus 23, and that's going to be equal to 8. So 2x plus 9x minus 69 is equal to 8. 3 times 23 is 69. So adding these two, we're going to get 11x, and adding 69 to both sides, adding 69 here disappears. Adding 69, I'm going to get 8 plus 69. 11x is equal to 77. 8 plus 69 is 77. And so dividing both sides by 11, I'm going to easily get x to be equal to 7. Okay. Alright, now to wrap this up, I'm just going to substitute 7 4x in equation 3. Remember, this is equation 3. And why? Because I already have y as my subject. So I have y is equal to 3 times 7 minus 23. So y is equal to 21 minus 23. Y is equal to negative 2. Okay. Alright. So that works out nicely right there, guys. Alright, so we're going to move on to question 12. Now, after this question, guys, what I'm going to be doing is just for the remaining 8 questions that I have listed on my file here, I'm just going to pick a random question. I'm going to pick 3 more random questions after this one, round off to about 15 questions, yes? And then from there, guys, that should basically give you a good idea of how to work all different types of simultaneous equations. So let's do this one and 3 more. So for this one, guys, I have to solve the simultaneous equation. Here we have 2y minus 5x equal 9 and 4y plus 3x is equal to 5. So the first thing I pick up here, guys, is the unusual setup of this simultaneous equation. We're so used to having the x and the y, the x at the front and the y at the middle, but now we have the y at the front and the x in the middle. So you have a choice here, guys. You can rearrange for your eyesight preference, how you're accustomed to seeing the simultaneous equation, or you can work it as per usual. All right, so here you can decide to equalize the y, or you can decide to equalize the x. For this one, what I'm going to be doing is that I'm going to be equalizing the y, although it's at the front. Okay. All right, good. So let's do that. So we're going to call this, of course, our equation 1. We're going to call this here our equation 2. Okay. All right, so here we go. So to do that now, guys, we're going to use the coefficient interchange technique, or we can use like the LCM method. They are kind of like the same, but there's a little bit of difference. So here, interchanging technique would have me multiplying this bottom equation here by 2, because this is a 2, and have me multiply up here by 4. All right, now what this does for me is that it will get these numbers the same, but it will have me working with some bigger numbers than I really have to be working with. Now what you can do here is use the LCM technique also, and for the LCM technique here, I recognize that the LCM of 2 and 4 is 4. So the question is, how can I get this number to become 4? That's simply multiplying by 2. And how can I have this number remain as 4? I can multiply it by 1. Okay, so a lot of persons may have a bit of problem when it comes to this, but as I said, there is a universal method that works, but it has a little disadvantage. It means that it have you working with numbers bigger than you have to. But if you know what you're doing, you won't make that mistake. So since, as I've already been preaching and promoting the coefficient interchange technique, I shall not stray from that. So I'm just going to say multiply this bottom equation here by 2 and multiply this equation here by 4. All right, but 2 and 1 works too. Okay, so here we go. So we have equation 1 times 4, and that will give us, or that implies that 4 times 2y is 8y, 4 times minus 5x is minus 20x, and of course 4 times 9 is 36, and that's equation 3 here. So equation 2 now multiplied by 2, that implies that 2 times 4y is 8y, 2 times 3x is actually equal to 6x. I'm so used to having the y in the middle. 6x, and 2 times 5 is equal to 10, and that becomes equation 4. Okay. All right, so now the signs are the same. So here's another fundamental error, guys. A lot of students, they do pay attention only to the signs that they are seeing here, but remember that I am not trying to equalize the coefficients of the x in this case. I'm trying to equalize the coefficients of the y, so I can't pay attention to these signs. I have to pay attention to the signs that are here. So it's a positive 8, a positive 8, same signs, subtract. That's according to the rules that we have. So we're going to subtract. So equation 3 minus equation 4 implies we're going to have 8y minus 8y minus 20x minus 6x is equal to 36 minus 10. So these two cancel out, and of course this is minus 26x, and that's equal to 26. 36 minus 10 is 26. So if I divide simply both sides by, of course, minus 26, I'm going to have x to be equal here to cancel out, minus 1. Okay, minus 1. All right, so now easily all I have to do now is just to substitute minus 1 for x in, of course I can choose equation 1 or 2. I like equation 1. Okay, equation 1. So equation 1 is saying 2y minus 5x is equal to 9. So that's 2y minus 5 times the value of x is minus 1, and that's equal basically to 9. So I have 2y is equal to negative 5 times negative 1 is positive 5, and that's equal to 9. So bring the 5 over, I'm going to have 2y is equal to 9 minus 5. So 2y is equal to 4. And if I divide both sides by 2, I'm going to get y to be equal to 2. So y is equal to 2 there. Okay, so we have gotten through another question here. All right, guys, so I hope you guys are getting it so far. I really hope you guys are getting it, and if you are at this stage, I would really love for you to smash the like button and also the subscribe button below, and don't forget to turn on your post notification bell if you have not done so already, and don't forget to share it. If I'm helping you, help me to help someone else, okay, by supporting my channel. So at this stage, guys, I just want to do about 6 or so more minutes and just pick some random questions for you. So we're just going to skip to the next page here. All right, so we've worked questions like this before, so we're just going to skip that one. And here's a question here with a different variable, so it's more or less the same. So I say what you can do is just pause the video and take a screenshot, or you can attempt these questions yourself. Okay, all right, so we've done questions like that before, and of course we've done questions like this one too. All right, and of course we do have some question. I believe that we just worked this question a while ago. Yes, well, let's work quad 16 here. Let's take a look at that one. Oh, all right guys, so we're gonna look at this one here, question 16. All right, so for this question, guys, it's not set up like a usual simultaneous equation. Apparently the question has been transposed to look a little bit different. All right, so let's dissect this question here. This question is tempting me to use the substitution method. All right, and it looks to be a really complicated question, but as you will see in the working out, it will be very short and quite easy once you know what you're doing. Okay, so here I definitely know I'm going to be using the substitution method. Reason being, I'm so used to my equal sign being after the x and the y, so this is not looking so normalized, if you want to call it, if that's such a word. It's not looking traditionally set up. All right, so here I recognize right away that I have two equations as per usual. Equation 1, equation 2. But what I noticed that in equation 2 I already have y as a subject, so I already have an expression that represents y. Y is equal to the expression 2x minus 7, but they also recognize that there's a y right here. So if there's a y there, why not substitute this expression that is indicated to be the value of y and put it right here? So we could do that. So we could definitely do some substitution here by saying sub y, which is equal to 2x minus 7 in equation 1. So it means that anywhere I see the letter y in equation 1, I'm going to put 2x minus 7. So I'm going to have simply 2 open bracket, since there's a y here, so, and y is 2x minus 7, so that's 2x minus 7. And then now that's going to be equal to x plus 10. And now I have an equation all in x. So distribution law here, 2 times 2x is 4x. 2 times minus 7 is minus 14. And that's equal to x plus 10. So I need to transpose like terms. So I have 4x minus x, bring this over, subtract x from both sides, and that's equal to 10 plus 14. Alright, adding 14 to both sides. So 3x is equal to 24. So if I divide both sides by 3, I'm going to get x to be equal to 8. Alright, so I've gotten through that part. So the question just looks difficult, or appears to be, but of course it's not as difficult as you think it is. So now I'm going to sub 8 4x in 3. Remember, this is equation 3. Okay, well, we didn't have a third equation. We did not need to create one because we already had our subject, so we can just substitute that in equation 2. So we have y is equal to simply 2 times the value of x, which in this case is 8 minus 7, and y is equal to 16 minus 7. Y is equal to 9. Okay, nice. So I hopefully you guys got that one there. Okay, fantastic. All right, so let's go on to another question that looks a little bit, I guess, off. So here, all right, so what we're going to be doing here is that we're going to be using here's another question like what we just did, so you guys can use what I just did a while ago to attempt that question. So that's a good question to take on. So we're going to do one more wordy question, I'm assuming here, but this time we're going to be dealing with some pounds and pence. All right, and this perhaps will be our final question for this series. Let me just go to the next page and see if there's another one here. All right, so you guys can try this one. All right, so just to highlight that 95 pence, when you're creating your equation, it will not be equal to 95, but it will be equal to 0.95, because 95 pence is less than a dollar, and this of course would naturally be 1.51. all right, so you're going to need your calculator for this one. Okay, all right, good. So without further ado, guys, we're going, and there's another one for you. So this is definitely going to be our final question for this video. So I'm going to be working a worded question with some pence and dollars for you here. All right, so here we go, taking our time to go through this one. So we're going to create our equations and stuff. So we have Alan and Connor have $6.70 in total. Okay, now Alan has $1.70 more than Connor. All right, so this is a strange looking simultaneous equation, but let's see if we can analyze it here, and we may be able to do even that last question there for you. So Alan and Connor have $6.70 pence in total. So pretty much they're not buying anything, but they're not buying anything at the moment. So pretty much what we have to do here is that we're gonna have to assign a letter to each individual. Okay, so we can simply say okay, so let Alan be represented by the symbol or the variable A, and let Connor be represented by the symbol C. We could do that, or X and Y, no matter. Okay, so here we have Alan and Connor. Okay, all right, so here we go. So Alan and Connor have $6.70. So basically whatever Alan has and whatever Connor has, it sums up to a total of £6.70. all right, now Alan has a £1.70 more than Connor. All right, so we know that Connor has Y. So, and we know that Alan has X. So whatever Alan amount is, so Alan's amount is going to be £1.70 more than what Connor has, and Connor has Y pounds. Okay, so hopefully you guys got that. Let me just repeat that for you. Okay, so Alan and Connor has £6.70, but specifically Alan, which has X pounds, his money that he has is £1.70 more than what Connor has. But we know that Connor has Y, so whatever Connor has, £1.70 more is what Alan has. Okay, so I'm hoping that that's clear for you. Okay, all right, so if that's the case, then this is the situation that we have. This is equation 2. All right, I'm from the Caribbean, guys, so forgive me if you hear me interchangeably talking about pounds and dollars. All right, so dollars is to pound as cents is to pence. Okay, all right, so I just wanted to make that verbal disclaimer there. All right, so here's the situation that we have now. That we have X is equal to £1.70 plus Y, we can sub equation 2 for X. All right, so X is here, and this is the value of X. So we have £1.70 plus Y again, because this expression here is for this X plus this Y, so it comes back here, is equal to £6.70. So £1.70 plus Y is 2Y, and that's equal to £6.70. So easily now we can just transpose this 1.70 to the other side. So we have 2Y is equal to £6.70 minus £1.70, and now we have 2Y that's equal to that's going to give us assuming here that's going to give us £5. So if we divide both sides by 2, we're going to get Y, which is what Connor has. Connor is basically going to have £3 and 50 pence. Alright, 5 divided by 2 is, well, this is actually £2 and 50 pence. So Connor has £2 and 50 pence. Okay, lovely. So now we're just going to substitute 2.50 for y in equation 2, which is this one right here. Okay, so we have x is equal to £1 and 70 pence plus £2 and 50 pence. So y is equal to £3, well, I should say £4 and 20 pence, and that's the amount that Alan has. Okay, all right, so that question was a little bit I don't know, maybe a little bit clear, so but hopefully you got it. All right, guys, so for the Caribbean students that are watching this, do ignore the pounds and pence. Your questions will always be posed in dollars and cents. All right, but at the end of the day, I hope you guys got the understanding. All right, so I do have some questions here. Of course, I know that you have already taken the screenshots of these, so that brings us to the end of our simultaneous marathon tutorial. This should take care of all your problems with simultaneous equation, and of course, if that objective has been achieved, please consider dropping a like and sharing this video to your remaining friends and families out there. I do take care. Until next time, Apex Alenia signing out, saying goodbye.